So this was the question put on Google Classroom, essentially asking for the derivative. So remember, there's a few things that we need to sort out. In this case, we've got an x in the denominator, we have a third, and we're going to have to simplify because of that bracket squared. So there's a few things that we need to do before we can even get into this. So remember your notation, keep the d of x there until you're done simplifying. This cube root we can write as, and remember, okay, sorry, let me backtrack a little bit. Remember that one of the formatting things that we have, or that we need to remember, or that is helpful to us rather, is if you say, for example, had negative x over 2, that can be written as negative a half x. Now, you don't have to write it like that. It's up to you. I find it a little bit easier when I start applying my the differentiation rules to have my expression written like that. I just find it a little bit easier. So this first term I'm actually going to write as negative a half, and then this cube root of x is x to the power a third. So I sorted out that first term, excuse me, plus, now there's a few different ways you can deal with the situation. Either you can deal with the x in the denominator first, or you can deal with the squared first. I'm going to deal with the squared first, but it really makes no difference. So remember, what we need to do is we need to multiply this exponent into my bracket, and it must be multiplied to each exponent in the term. So 3 has an exponent of 1, x an exponent of 1, and 1 an exponent of 1. So this simplifies to 1 over 9x squared. Right, then I'm going to just finish off dealing with that last term because I still don't want that exponent in the denominator. First term stays as it is, it's sorted. But this now becomes plus 1 over 9 x to the power negative 2. And again, I write it next to the fraction just because I find it a little bit easier to then do my differentiation rules. Right, now I can find the derivative because it's in the form I want. First term, take the exponent, multiply it by the coefficient, so negative a half times a third. Now remember, because I'm finding the derivative, I can drop the notation. Negative half times a third is negative 1 over 6x, and then we subtract 1 from the exponent, so a third minus 1 is negative 2/3, so it's the power negative 2 over 3. Move on to my second term, do exactly the same thing. Exponent times coefficient, so negative 2 times 1 over 9 becomes negative 2 over 9. X to the power, subtract 1 from that exponent, leaving me with an exponent of negative 3. Right, now, as I said to you guys on Monday, don't bother trying to deal with those negative exponents. That's not something I'm marking here. The purpose of these questions is not to check whether or not you can make it a positive exponent. The purpose of these questions is to see whether or not you're capable of finding the derivative. So there's no need for you to change it back into thirds and fractions and all of that sort of stuff. There's no need for that. You can, obviously, if you want to, but there's absolutely no need. I would advise against it because I think Lorato asked the question. Technically, if you now go try and do that and you make a mistake, we technically have to mark your final answer. And so we would then be marking an incorrect answer when you would have gotten it correct here. So just stop. Don't try and deal with the negative exponents. There's no need to do that. Okay, so Tintwalo, I hope that answers the question. And I hope for everyone else, this was a really, really nice derivative question. This is definitely something you can expect in finals. So hopefully that helps. Right, I'm just going to wait in case you want to take a screenshot. I'm just going to chat a little bit. So like I said, guys, we're going to have a look at some cubic functions today because that's the other big part of calculus. So your calculus, you kind of have 3 types of questions: finding the derivatives, either using first principles or the rules like this one, cubic functions, and then a very, very small section is the optimization. I'm hoping we'll get to an optimization. I'm not super confident, but it is a very, very small part of these 35 marks. So if we don't, it's not the end of the world. You can go and practice that and ask me questions as you go along. But the cubic functions is very important. Excuse me. Alrighty. So this is not where I want to be. Sorry. Okay, so this is the question we kind of stopped at, and I said, cool, we'll come and have a look at this on Wednesday. So let's see what we have. Some of these, exactly as I've said before, I'm going to ask you to do by yourselves. Some of them I'm going to do with you. I will let you know when I want you to do what. But just ask me questions as we go along if anything is confusing or you're not sure about something. Let's see if we get the mark application. Okay, cool. So it says, given f of x is equal to x cubed minus x squared minus px plus q, point t at negative 4/3, 18, and 14/27 is a stationary point, and f of negative 3 equals 0. A and b are x-intercepts. So I'm not even going to get into the actual questions yet. I just want us to understand a few things before we jump into it. So first things first, grade 12s. Whenever I give you an equation and there's only certain unknowns, so here we've got the p and then we've got the q. We know that a cubic function has the general formula ax cubed plus bx squared plus cx plus d. You can, with confidence, assume that a is equal to 1 because that's the coefficient of x cubed, and you can assume that b is equal to negative 1. So if we give you part of the expression and we kind of show you what those coefficients are, you can assume that's true. Right, the second thing that we've been told is that t is a stationary point. So remember, we spoke about this on Monday. Stationary points, turning points, it's essentially the point where our first derivative is equal to 0 if we were to calculate it. And then this is function notation, which I know some of us aren't super comfortable with, but we do need to be comfortable with it. So it says f of negative 3 equals 0. Now remember, usually this would say f of x. So what we're doing here is we're giving you the x value. So I'm telling you x is negative 3, and where x is negative 3, the y value is equal to 0. And so what I'm actually giving you here is an x-intercept. And if you go and have a look at your graph, you've got an x-intercept on the negative x-axis and an x-intercept on the positive x-axis. Because this is a negative x-intercept, we can say that A has a coordinate of negative 3, 0. So the function notation is really important. It's important you understand what it's saying to you because this gives us information that could potentially help us. All right, so, excuse me, 7.1 is asking for, is asking us to show by calculation that P equals 8 and Q equals 12. It is worth 4 marks. I feel like I made a real mission of this in terms of my calculations. I wonder if there was an easier way to do this. Because if I'm looking at my answer now, it is not worth 4 marks. But anything's possible. Maybe we were just stingy. No, it looks like we're just stingy. Okay, sometimes stingy happens. It's not an ideal situation to be in, but it is what it is. Okay, so let's have a look. I would definitely probably allocate more marks. I also may very well have written down the mark allocation incorrect. I can double check that as well because it is entirely possible that I made a stupid mistake. No, 4 marks. Okay, so we're just stingy. It's fine. Right. So it says show by calculation that P equals 8 and Q equals negative 12. Now remember, when we are finding, let's just say in general, if we're finding a cubic functions equation, there's 2 ways that we can do this. Way one is to work with the x-intercepts if we've been given them. So if I know where my x-intercepts are, I can use the x-intercept form of my equation, so the 3 brackets representing my x-intercepts, and I can then go from there. Option 2 is if you've been given a turning point and if you have then been given some other piece of information. Now, in this case, we've been given the turning point and some other piece of information. Now, unfortunately for us, it often does mean that we're going to work with some nasty values. It just is the reality, unfortunately. But what we need to go back to is, what do all of these things represent for us? Okay, so because I have been given a turning point or a stationary point, I'm going to start there. And remember, we said that the stationary point or turning point on a cubic function is where your first derivative is equal to 0. So let's have a look at that. We have got f of x, which is the x cubed minus x squared minus px plus q. And if we were to go and find the first derivative of that, we would make that equal to 0, but we also would know that the x coordinate at that point is at -4/3. Because if we go to our turning point, that is the x value of my stationary point that I was given. So let's find the first derivative. So my first derivative here would be 3x squared minus 2x minus p. And remember, q represents a constant. And we know that in derivatives, the constant falls away. So that becomes 0. So this is quite nice. What I've been able to do here is I've been able to get an equation or an expression that just has p that I need to solve. And the reason it has p I need to solve is because I know that my first derivative is equal to 0. And I know that my x value at that point is equal to -4/3. So every time I see an x, I can substitute that with -4/3. So I get 3 times -4/3 squared minus 2 times -4/3 minus p. And what this is going to allow me to do is it's going to allow me to solve for p. So sorry. I'm also now choosing to do things in a completely different way. So. Right, so we substitute that all into our calculator. Oops. Right, so if I take those first two terms and I subtract them, I get 8. So 0 is equal to 8 minus p. And so p is equal to +8. And if you go and have a look, it says show that p equals +8. So that's great. I have that sorted. Now I just need to go and find q. Now remember, guys, q represents your y-intercept. And unfortunately, we don't know what that is. So it's not an ideal situation, but it is what it is. Because I do know p, however, I can substitute that back into my equation so long. So I've got x cubed minus x squared minus 8x plus q. And remember, I said there's 2 ways to do this. Either with your x-intercepts, which we couldn't do here because we don't know all of them, or with your turning point. So we have used the turning point, or rather with your turning point and another coordinate. We've used the turning point. We've used the first derivative. We've gone and found what p is. That's great. But the other piece of information I was given that I haven't yet used is the fact that I do have one x-intercept at -3. So what I'm going to do is I'm going to substitute in that coordinate. It's a coordinate on my graph, so it follows the rule. And if I go and substitute in -3, 0, what I'm going to see is that I end up with an equation that allows me to solve for q. So again, if we type all of that in, I'm just making sure that I still get the same answer by doing this. We get that 0 equals -12 plus q, and so q is equal to +12, which once again is exactly what we wanted. And so now I know that my equation of f of x is x cubed minus x squared minus 8x plus 12. Now, I didn't ask for the equation, just asked for values. So you've done that. You don't need to do anything more there. But don't know where I was going with that. Sorry, my brain's a little bit fuzzy today, clearly. Caleb Ogelia, question?
Ma'am, on the first one, we were looking for P.
Yeah?
But the x-intercept is minus 3, but I see it's a positive 3.
Where do you see a positive 3? Sorry?
Ma'am, more f of x equals to more the green part.
Okay, but remember, that's my derivative. That's got nothing to do with my x-intercept. This is the derivative.
Okay.
So when I find the derivative of this x cubed, it's multiplying the 3 by the coefficient. So that's why it's 3. And then I subtract 1, so 3x squared.
Okay, ma'am.
Okay.
Thank you.
Sure. All right, so guys, I'm just going to say it again. 2 ways that we generally have to find our cubic function. Either I will give you the x-intercepts. Maybe let's do a little blocky here so we can summarize this. Terrible block, but hopefully we get the picture. Right, so either I give you the x-intercepts, and you can then use the formula a times x minus x1, x minus x2. Move this over. I will make it smaller in a second. X minus x3. You can sub in your x-intercepts, and generally we will give you another point that you can then substitute in to find a. Or we will give you the turning point and another coordinate. In this case, it was an x-intercept, but it could be any other coordinate. We would then go and find our first derivative equal to 0 and sub the x value or the x coordinates of our turning point or our stationary point. Turning point. And once we've done that, we would then sub in our other point in order to find our coordinate. Now, this question you actually could have done with simultaneous simultaneous equations, which is actually what I did initially. But like, why? What a mission. As I was talking earlier, I realized I was being a real nana-bean. So those are the two main ways we can do it. Rato, I do see your hand. I just want to do the mark allocation because I will forget otherwise. So in terms of your 4 marks here, you would get a mark for finding your first derivative, a mark for, and guys, remember very, very importantly, this question says show that these values are true. So you are not going to get marks for telling me that P equals 8 and Q equals 12. You also may not use those values in your working out. That should be like a final answer value. So you get a mark for finding the first derivative, a mark for substituting in the x coordinate of your stationary point. You then get a mark for yes, you get a mark for substituting in the other coordinate, in this case, x-intercept, and then you will get a mark somewhere for some sort of simplification step, right? So generally in these questions where we say show that, prove that, whatever, we give you marks for your ability to simplify. Okay, Lorato?
Hi, ma'am.
Hi.
So, ma'am, I have a question whereby would it ever be possible that in this type of question they don't give us, I would say, a second point? Maybe they just give us the formula of the graph and just point T, and then they make us calculate the values of P and Q.
Not with only 1 point. It's not enough information to calculate with only 1 point.
Oh, okay, ma'am.
Okay. So if anything, they might, I'm trying to think of how they could ask this. Maybe they could give you like a cubic function, something like that, and then a hyperbola where the asymptote of the hyperbola goes through a turning point or something like that, and then you could substitute, but honestly, that's just way too complicated. So no, we need to give you at least 2 points in order for you to do that. Okay, hyperbola is a poor example, maybe like a parabola and like the turning point. Yeah, you get my drift. We'd have to give you something where you can get the information. Alrighty. And remember, guys, any questions as I go along, please ask. Like I said, I made some choices here in doing simultaneous equations, and I'll show you how absolutely gross it looked so that you can see the absolute chaos. So this is the, hang on, I don't actually know what I'm showing you. So this is the grossness of a simultaneous equation. Obviously, you can do it. Can't really see, but look how gross that is. Look at that. Yeah. Nonsense. It's horrible. Okay, so don't do simultaneous equations if you don't have to. Why make life hard? Okay. You can do it if you feel that way inclined, but don't. Alrighty, I did see a hand. Tinswallow.
Ma'am, when we're calculating, is our first derivative always going to be 0?
The first derivative is always 0 if it is a stationary point, yes.
Oh, okay, thank you.
Okay, so in this case, because it was a stationary point, that's why I made it equal to 0.
Okay, thank you.
Pleasure. Okay, cool. So we have got our equation. That's great. It does mean that we now have a few more pieces of information. Because Q is positive 12, I know that my coordinates for C are at 0, 12, because remember, that's your y-intercept. I don't really know much more than that, but at least I have another coordinate. So 7.2 asks for the length of AB. Now, AB is a horizontal length. If we go and have a look at where it is, here is AB. And if you kind of consider what points those are specifically, it's the distance between your two x-intercepts. So we already know that A is at -3, 0. We would have to go and factorize and essentially find the other coordinate of B. Now, I'm going to ask you to try and factorize by yourselves. But remember, because we know the equation now of my cubic, and because I do know that A is an x-intercept, technically, as I start to factorize this expression, I already know one of my brackets. Now, remember, when you put it into your brackets, you always change the sign. Because if I were to now go and solve this and make this equal to 0, I want to get that -3. So we always swap the signs so that we do actually get the correct. Sorry, I'm hearing weird noises. So we do actually get the correct x-intercepts. So technically here, I actually have my first bracket. I would just need to go and completely factorize the rest of this expression to get my coordinate for B. Now, a quick little side note. Please remember that when we have a situation where we have both an x-intercept and a turning point or a stationary point. So point B is an x-intercept and a stationary point. This means that when we factorize, we get two identical brackets. So it almost gives away that these two brackets that we go and factorize here should be identical. All right, so I'm going to give you like 2 minutes, not even 1 minute, 90 seconds to factorize this expression. And if you want to go the step further to find the coordinates of B, but actually, no, go the step further. So factorize, find your coordinates of B. So I will give you 2 minutes. And if you can then find the length of AB, awesome. But otherwise, factorize coordinates of B, and then we'll wrap it up with the length of AB. If you have questions, ask. Remember, factorization methods, either synthetic division or the factor remainder theorem. I've already given you one of the factors, so you just need to find the remaining quadratic to then go and factorize if you're going to use that method. If you aren't, I really hope I remember how to do synthetic division. I have given you a factor, and you can now go and use that to divide into your remaining coefficients. And our synthetic division experts just tell me if I'm wrong. I need to practice it. I'm fully aware of the fact that this is a me problem. I need to practice. I know that. All right, guys, don't forget, you can put answers in the chat. I'm going to give you 1 more minute, and then we're going to have a look. Alrighty, let's have a see. Okay, so again, I'm fully aware of the fact that I need to practice synthetic division. I take that on. I know I need to do it. I'm going to use factor remainder theorem, but you will get exactly the same answer if you do synthetic division. So you would get a quadratic here of x squared minus 4x plus 4. And when you then go further to factorize that quadratic, you end up with x plus 3, obviously, and the x minus 2, x minus 2. And this is exactly what we were saying now. You should get 2 identical brackets. So what this tells me is that my x-intercepts, when I make, obviously, that equal to 0 and solve for my x-intercepts, are at x equals -3, which I already knew, or x equals +2. And so now what I have is the coordinate of B. And now I can work out the length of AB. If A is 3 units away from my origin on the left, and if B is 2 units away from my origin on the right, that means that AB in total is 5 units. Right, so it's just a counting situation once you have that thing. Oh, Tori saw. Okay. I can't remember synthetic division. I'm so useless. Anyone want to explain synthetic division? Cool. Cool. I don't really want to make it up, but let's see what happens. So I know that I have my factor of 3. Connie. Are you going to help me?
I can explain it. Let me just finish quickly.
My champion. Okay, so Toriso, like I said, I'm useless. That's okay. And Kani is going to help us out. And I'm hopefully going to try and... Actually, Kani, if you can put your camera on and then I can write as we go. But if you can't put your camera on, that's absolutely fine. I'll try and get it as I go along.
Okay, ma'am. Let me just finish quickly.
Yeah, no stress. Toriso, this is my my homework. I have it.
Okay. Okay, so once you've gotten like the -3 that you have, you're gonna write down. So we're gonna go to our equation here, and then you're gonna write down.
Is your camera on?
Yes, ma'am.
Sorry. Oh no, because I'm just a little bit stupid. I'm clearly having a day today, so please just you continue. I got you. Okay.
So once we go to our equation, and then we get like the variable. So the 1 here, we're gonna put it here, and then the -1 by x squared, we're gonna put it here, and then we're gonna take the -8 by -8x, and we're gonna put it there, and then you're gonna draw a line, and then you take the constant, which is 12, and then you put it on the side. So once you have that, you're gonna write across here for multiplication, and then you put a star over here. Then you're gonna bring
Why
down
do I put a star
your
there? Sorry.
It's like to show that you mustn't write anything there. That's what our teacher told
Oh,
us.
because
Like,
it won't
just
be a
make
Q.
sure-
Okay.
Yeah, so you don't put anything there.
Okay, cool.
So you're gonna take your 1, and then you're gonna drop it down, and then you're gonna say -3 times that 1 that you dropped, and then you're gonna put that -3 at the top. Then you're gonna say like -3 plus -1 is gonna be -4. Then you say -3 times -4, and that gives you 12. Then you write it there. Then you say 12 plus the -8. Then you're gonna get 4, and then you're gonna say -3 times that 4, and then you get -12, and then you say -12 plus 12, and you get 0. And then a way to know if you're on the right path, you must always get a 0 here. And then if you don't get a 0, then you must just go back and like check your working out. And then you're gonna say x plus the 3. So that -3, you basically change the sign. So if it was a +3, you change it to -3. And then since it's -3, you're gonna say x plus 3. And then you're gonna open another bracket. Then you're gonna take that 1. Then you're gonna say x 1, like x squared for that 1. Then you're gonna say -4x, and then you're gonna take that constant and bring it down. I hope I explained it properly.
That was perfect, and I'm following along with you on my screen. So hopefully, hopefully we're all getting it. +4, perfect, and then you end up with what I was at there. thank you. I promise you this is my homework for the weekend, can you?
Yeah, ma'am.
Oh, guys. Sometimes it's not good to be stuck in your ways, as I have just proven. Okay, so Tomoriso, I hope that makes sense. It made sense to me, so hopefully we're good. Obviously, just let me know if we're not. And guys, I did follow along on the screen with Kani's explanation, so I have written it down. These beautiful arrows that I have going on here, which I'm just going to make a little bit clearer. So these arrows here, that's the multiplication. So it's the -3 being multiplied with all of those values. And then remember your products go up here at the top, and then you're adding and subtracting with the things. These numbers at the These numbers at the bottom over here are your coefficients, as I've said, to your quadratic. Okay, cool. I promise you I'm going to practice this. Also, because I think you also explained another one for us, and that was where I was getting confused. So I have your videos. I can learn. Okay, so I'm just going to stop here in case we want to take a screenshot of this beautiful masterpiece that we have here on the screen. And then we'll have a look at the next question. Lorato?
Ma'am, do you mind also including the mark allocations for both? For both the one we did, the factor theorem, and how would the marker distribute the marks with the synthetic division?
Cool. Okay, I'm going to be honest. In terms of synthetic division, we very rarely actually have... there were words that I was going here with. There's very rarely ever a memo allocated for synthetic division. So I'll tell you what I think would happen, but I'll get there. So in terms of the factor remainder theorem, you would have to essentially have your correct binomial bracket and then getting your quadratic. So that would be an answer. Factorizing your quadratic, getting essentially that B was a coordinate of 2, 0, which I put up here, but I'm just going to put it there, and then getting your final answer. Synthetic division, I would assume, like I say, I assume I've never ever seen a memo option using synthetic division, but we will mark it. Just because it's not on the memo doesn't mean we won't mark it. Synthetic division, I'm assuming you would likely get a mark for your working out, a mark for getting that appropriate quadratic, and then it would be the same 2 marks over here, getting your B coordinates and then getting your distance. So like I say, it would be, in both cases, it's one method mark, the complete factorized product, etc., etc. But like I said, I've never actually seen a memo option with synthetic division. I'm not too sure why, but like I said, we will mark it. I don't know why they don't put it as a memo option. I'm not 100% sure. I will try and find out. But like I said, we will still mark it. It's just, yeah, that's how we would do it. Okay, so if you want to take a screenshot still with the marks, I'll leave it there, and then we'll have a look at the next one. Okay, so 7.3 is asking for which values is the function concave up. Now remember, concave up, or concavity in general, let's start there, is dependent on the second derivative. So concave up is this portion of my graph that looks like a happy face. I need to know what my point of inflection is before I can go and say where it is concave up, because it's specifically asking me for the x value. So I would first need to work out what my x value of my point of inflection is, so that I could then say it's all the x values greater than that, because that's where my happy face is. Right, so does anyone remember what method we used to find point of inflection? So essentially, how do I find it? Anyone remember? Lorato?
Do we find the second derivative and make it 0? Then we basically solve for x.
Perfect, exactly. So our point of inflection is where we would take the second derivative and make it equal to 0. Now, Great Tolls, you've got options here. If you understand that concave up is where your second derivative is greater than 0, you don't necessarily first have to find the point of inflection and then solve from there. You could solve the inequality, but if you're not super comfortable with inequalities, find the point of inflection and then you can go from there. So it's really up to you how you choose to do it. Completely your choice. You can decide that. So I want you to do that for me. I'm just going to write down what f of x is. So obviously to find the second derivative, you first need to find the first derivative, and then you find the derivative of that. So you need to find the second derivative, either make it equal to 0 or use the inequality greater than 0, and give me the x value where this graph will be concave up. Kani, Owami, and Leila, sorry. Well done, guys. I do see your answers on the chat. Well done, second derivative. Right, I'm going to give you 3 minutes to do that, and then we will have a look. 3 minutes because 3 marks. Alrighty, let's have a look. So that was 3 minutes, and don't stress if you're not done, but you kind of just get an idea of your time management. So first things first, we have to find the first derivative. That looks a bit better, Lorato. Thank you. Okay, so first derivative is 3x squared minus 2x minus 8. Second derivative, we now find the derivative of that, 6x minus 2. So option 1 is to do an equation. So say 0 is equal to 6x minus 2. I'm just going to carry on up here, which means that 6x is equal to positive 2, which means x is equal to a third. Option 2 is to use the inequality. So to say, okay, cool, I know that my second derivative must be greater than 0 for it to be concave up. So I would take 6x minus 2 and make that greater than 0. And now I'd solve my inequality. Now this gives you your answer immediately. Okay, so remember the question said, for which values of x is the function concave up? And I said to you that as long as we know where our point of inflection is, I then know it's all of my x values greater than, because it's all of the positive x values or to x values to the right. So that method with the inequality gives you your answer immediately. You don't need to stress. If you're going to go the equation route, you've now found the x value of your point of inflection. You then have to go the step further and actually write it out as an inequality to give all the x values. Now, just quickly, Lorato put on the chat there the whole coordinate of the point of inflection. In this case, you don't need the whole coordinate. You just needed the x value. So it wasn't necessary to find the y coordinate. However, if you were asked to determine the point of inflection, you would then substitute this x value back into the original graph, because remember, it's on f of x. So we substitute back into the original in order to get our y. But in this question, it wasn't necessary. Mark allocation is finding your second derivative. Second derivative, understanding that it must be equal to 0 and then getting your final inequality. Alternatively here, setting up your inequality greater than 0. Obviously, again, finding your second derivative and then getting your final answer. So yeah, those are your 3 marks then. 7.4 then asks, determine the equation of the tangent to the curve at the point where f of x changes concavity. So we know already that at the point where a graph, specifically a cubic function, changes concavity, this is our point of inflection. And we already know that this has an x coordinate of a third. Obviously, if you've worked out y, great. If you haven't, that's also not the end of the world. Right, I just want to scroll back up to the graph so we can understand what we're actually looking at here. So the question is saying the equation of the tangent of the curve. Now remember, point of inflection is the moment where your graph, your tangent line flips over. So we are essentially looking for that tangent line over there. It's in no way clear, so let's try that again. I'll make my pen a bit thicker so we can actually see what I'm doing. Okay, we're looking for this tangent line over there in yellow, at this point of inflection. Now, there's a few things that we need to remember when we are looking for tangent lines. First thing being is that a tangent is a straight line. And so this needs to follow y equals mx plus c. So I need to find the gradient of this tangent line, and I need to find the c value of this tangent line. Now, what we need to remember is that first derivative represents gradient. So the first derivative will tell us the gradient of or at a very specific point. Now, we've already worked out the first derivative. We already know that this is 3x squared minus 2x minus 8. So this expression that I have already found gives me an expression for the gradient. So this represents my gradient. I know that I am specifically looking at the specific coordinate of a third. And so what I can do is I can substitute in my x value, because I know that I'm looking for the gradient at that specific coordinate. So I can now go and find what the first derivative's value is when x is a third. Just substitute it in. Okay. And I get that this is negative 25 over 3. Now, if we just quickly jump back up to my graph, we can see that that yellow line is definitely a negative gradient. It's decreasing from left to right, so definitely a negative gradient. So I now know y is equal to negative 25 over 3 x plus c. Okay, terrible 3. We'll try that again. Now all I need to do is find my y-intercept. Now remember, in order to do this, you need to substitute in the point where your tangent, or a point that your tangent goes through. And we can only do that using our original function. So this is now what Lorato did earlier, we're going to have to do. I know that my graph passes through this point of inflection, so I need to go and find that y coordinate. Now I have to go back into my original function because that is the function through which this line passes. So it will be a third cubed minus a third squared minus 8 times a third plus 12. And as Lorato correctly said, this is 250 over 27. So we now know that our point of inflection has a coordinate of a third, 250 over 27. Unfortunately, guys, these values are often not nice, particularly for points of inflection. So it just is something we got to roll with. And now what I can do is I can substitute that into my straight line. So again, y equals negative 25 over 3 x plus c. I'm going to substitute in this coordinate. So I get 250 over 27 equals negative 25 over 3 times a third plus c. Now I'm going to be honest, there's no way I want to go and calculate all of that, so I'm just going to use my inverse operations. And what I will type into my calculator is this entire left-hand side all in one go, because that will give me c. And my c value here ends up being horrible, 325 over 27. Yep. And so my equation is y is equal to negative 25 over 3x plus 325 over 27. So great tools, please don't panic when you get these horrible values, particularly when we're talking about points of inflection where you've worked out your x value to be a fraction. They're going to be gross. Okay, it sucks, I know, but they're just going to be ugly. So just the mark allocation here so you can see it. You are going to get a mark. You're going to get a mark for obviously calculating this y coordinate. You're going to get a mark for calculating the gradient. You're going to get a mark for finding your c value, so substituting to find your c value, and you're going to get a mark for finding your final equation. So 4 marks here. Like I say, not nice numbers, but some, like, you've done this before. We've found equations of straight lines before. We've been doing it since grade 8, grade 9. It just so happens that the values are really ugly, and we do have to use derivative to find gradient. So the really, really important thing with these types of questions is the fact that your first derivative represents the gradient. Okay, that's such an important point to remember, because if we don't remember that, we are going to struggle to actually answer our question. I'm just going to make that a bit lighter. Right, any questions thus far? Obviously, I know you'll ask me questions, but I'm just making sure. All right. I just want to bring this graph down so that we can talk about what's happening. because I know these are questions that we often don't like. Alrighty, Ru. So 7.5 is asking us if f of x equals k has one distinct real root, determine the value or values of k. All right, so let's just establish a few things. Oops. The situation of f of x equals k. Remember, k is a constant, so k represents a horizontal line, but let's just understand. So f of x is x cubed minus x squared minus 8x plus 12 equals k. So what's really important is that we understand that k is a horizontal line. And this is just going to be quite useful when we go and visualize this in a second. And generally what that then means is we're talking about an up or down transformation or translation. So we're going to move the graph up or down in order to get what we want. Right, the next thing that we need to understand is what do we actually want? So the question says, I want specifically one distinct real root. So what that means is, if we have this cubic function over here, I only wanted to cut my x-axis once. This is one real distinct root. Remember, roots are your intercepts to your x-axis. So if we go and have a look at our graph, we now need to understand what that means in terms of our graph. So here's my cubic function. Okay. And let's have a look at some of the options we have. So option one, hopefully fairly obviously, is I could move it up. If I can move this graph up, it means that I'm only cutting the x-axis once. But the second option I have is also to take this function and move it all the way down so that that turning point or that stationary point t is below the x-axis. So I've got two options. Again, option one is I can take this entire graph and move it up, so shift the stationary point off the x-axis so that now it only cuts once, or take my cubic and shift it all the way down so that t is below the x-axis, and this arm will just keep going up, intersecting my x-axis once. Right, so I have a few options here, and now I need to essentially write down those, values for k. Okay, so the important thing, like I said, is to understand that k is a horizontal line. I think we were given the coordinates of t. Obviously, t is an important point here. -4/3, 18, 14, 27. I don't know if I'm going to remember all of that, but we'll see how we go. So t is at -4/3, 18, and 14 27ths. And I think we worked out the coordinates of b, unless I'm just imagining things. We did. B is at 2, 0. Okay, so I need to remember option one is to move this coordinate of t all the way down past the x-axis. So that means I need to move it greater than its y value. So 18 and 14 27ths is something silly. Sorry. 18 and 14 27ths is 18,51 units. So basically, as long as I move it just more than 18,51 units, it's going to go below the x-axis. So I must move it just more than 18 and 14 27ths. Why we chose this value, I have no idea, but there we go. So k must be greater than, because remember, you would be moving it down. And if we were to bring that k over, it would become negative k. So that's why if I were to substitute in a positive 18 and 14 27ths, because of the negative in front, it would become negative 18 and 14 27ths, indicating a movement down, negative. right? These are really hard because if visualizing what the k sign is, that's where we get tripped up. Honestly, that's where I get tripped up with these. So this is option 1. Option 2, we said, is to move it just enough units up. Now, again, think about this logically. B is on the x-axis. So even if I move it 0,001 units up, it's no longer on the x-axis. So I just need to move it up more than 0 units, and I will then have one real distinct root. Now remember, I wanted to move up, which means that, again, think of what happens when you are working with this k value. So k would have to be less than 0. It kind of is a bit confusing because you want to move up, but let's say, for example, k was -1. If I substitute a -1 when I bring that k over, I would have minus -1, which indicates a +1, shifting 1 unit up. So like I say, guys, these questions, what often gets us is just the signs of k and what they are when we are working with it. Right, but my best advice with these types of questions is to try your best to visualize what's happening. Try your best to understand that k is a horizontal line. So granted, I didn't draw a horizontal line, but if I did, just draw horizontal. What this is saying is that, it's going to fight with me. This horizontal line would essentially need to cut my graph once. So this is, again, cutting below the x-axis, so shifting that down, cutting once, so having to move that whole graph down to get one cut. So k will represent a shift up or down. That's the way I remember it because it's a constant. And 9 times out of 10 with these sorts of questions, the turning points of the stationary points are quite important. They will probably be 80-90% of the time the values of k that you're going to work with. But just think logically about how you need to move it. The trick is in understanding the sign of k, and I do understand that that's tricky. Like I said, I struggle with it still, but understanding the sign of k so that you can then get your inequality correct is going to be important. Excuse me. The 2 marks here are just for the 2 answers. There's no like working out method marks here. So your 2 answers, it would be an all or nothing. So what I mean by that is if you accidentally put the inequality the wrong way, you would lose that mark entirely. Right, I think let's take screenshots at this point of these questions. Otherwise, it's going to get a bit squished. And then we'll have a look at 7.6. All right. So 7.6, and again, I'm going to use my graph. I'm just going to take the green off. So 7.6 is asking, give the values or values of x for which f of x is greater than 0. So again, we need to understand what this means. F of x greater than 0, it's asking me essentially where is the cubic greater than 0, which is essentially saying where is my cubic positive. So the y values must all be positive. So we're looking over here. And if you go and have a look at your graph, it's kind of almost the entire graph. It's from this coordinate A all the way. We get to the turning point at B. That's where it's equal to 0. I don't care where it's equal to 0. I care where it's positive. So except for the 2 x-intercepts, my graph is pretty much positive except for this little sort of section over here. So this A value was at -3, 0. And I essentially want all of the x values greater than that except for at that turning point. Because the inequality is not asking me where is it greater than or equal to 0. I don't care that it's equal to 0 here. I care about where it's greater than. So it's all of my x values, like I say, greater than -3, because that's where it's all positive. But we have to discount where x is positive too. So we have to discount that turning point from my answer. And so you are going to get answers for the inequality and then understanding that you need to ignore the positive too. Right, again, I know that these questions aren't necessarily the easiest of questions. I get that. But again, think carefully about the inequality, what the inequality rather is saying to you and what it's asking you. I'm going to wait for you to take screenshots, but while you do that, Lorato. Lorato? Oh, there we go.
Yes. Yeah. So, ma'am, with this type of a question, is there ever would we ever get a question whereby we need to consider the x-axis? Because I know for this one we mainly considered the y-axis, like the y values, but would we ever have to look at the x values in order to deduce? Yes. And if so, how would it be asked? Is it similar or different to this one?
I've never seen a question for why. I suppose it could, but I've never seen it asked. If you're asking me how it would be asked, let me just think of this. Let me just think about this. Which values of y? The y values are more asked as range questions. Okay, so I'm trying to problem solve it in my head. So for example, if they said for which values of y would x be greater than 0, for example. X greater than 0 is all of these x values here, which means that my y values correspond to where y is greater than 0. But these are also y greater than 0 values, but x is negative there. So that's a bit of an issue. Like I said, we more ask you range questions or, and I have the question in my head now, or or they will ask you within an inequality where they say x times f of x greater than 0. They'll still ask you for the x values, but then you still have to look at the x values to figure out what's happening there. So for example, this inequality, it would say for which x values is x times f of x greater than 0. Essentially, you either have to have a positive times a positive or a negative times a negative. So if we look on this side of our function, x is negative, y is positive, that's not going to work. But here, x is positive, y is positive, so it would be all of these values for x, except for my x-intercept. So we can kind of ask it like that in an inequality, but we never really ask for which values of y. I've never seen it asked. I hope that answers. I know that was a bit of a roundabout way of getting there.
Okay, ma'am. I get you. Thank you.
Sure. All right, guys. Okay, I hope you've got your screenshots. I'm going to ask you to try one by yourselves now. Okay. Okay, so this is what we did on Monday. Right, so I know there's a hyperbola on this graph. It's not super important. We're more focusing on the cubic, which is graph F. But let's have a look. So it says, in the diagram below, the graphs of f of x equals ax cubed plus bx squared plus cx plus d, and g of x equals 2 over x plus p plus q are given. Excuse me. E is a point of intersection of the graphs f and g. F is the point of inflection of f. The graph of f cuts the x-axis at a half, touches it at -3, and cuts the y-axis at 9. So cuts the x-axis, it means it goes straight through. Touches means it's both a stationary point and an x-intercept, and then obviously the y-intercept. So we've been given a fair amount of information here in order for us to go and answer our questions. And the first question says, show that a equals -2, b equals -11, c equals -12, and d equals 9. This is a show that question. So you may not use those values anywhere in your working out. I don't want to see them in your working out. What you need to use are the x-intercepts and the y-intercept in order to go and solve for A, B, C, D, and E. Remember, -3 is both an x-intercept and a turning point. So that might be useful to you, but you have got more than enough information to go and find those values. So this is a 5-mark question. I'm going to give you 5 minutes. Ask me questions on the chat. Put your answers on the chat. And remember, I did say earlier, we've got options or multiple ways that we can do these types of questions based on the information we've been given. So think carefully about what information you have and how you can use that to answer this question. 5 minutes. Alrighty. Again, if you're not finished, don't stress. But again, this is kind of like a time management lesson. See how far you've gotten, how far you would still need to go, and just make sure you are sticking to those times. Alrighty, so I even showed mark allocations here. In this case, because you were given both x-intercepts, that helps, all right? So what you would do here, and I'm not saying this is the only way to do it, you definitely could have used first derivative for your turning point like we did with the last question. But because you were given both x-intercepts, you are able to substitute that into the x-intercept form of your equation, all right, with the 3 brackets. But because -3 is both a stationary point and an x-intercept, it means that you've got the brackets squared, and those are my x-intercepts subbed in. Then you can substitute in the other coordinate you have, 0, 9. And what that does is it allows you to go and solve for a, because you're substituting in for x and for y, and so the only variable you have unknown is a. So you get your value of a. You would then substitute that back into this x-intercept form of your equations. Now we've got -2 and then my x-intercept brackets. I can then distribute all of that out and I get my values of a, b, c, and d. Like I said, I'm not saying that you can't use the turning point, first derivative, all of that like we did in the question we started with. It's fine, but I did it this way just so that you could see how you would use the x-intercepts and that coordinate. Right, there's your mark allocation, a 5 marker. So a decent chunk of marks, but hopefully not too tricky. Alrighty. So the second question here says determine the coordinates of f. F, we were told in the information of our question, is our point of inflection. Oh, okay, cool. Point of inflection. And so I want to know the coordinates of that point of inflection. Right, so again, I want you to try it by yourselves. I'm trying to underline point of inflection, but I'm just doing it really badly. You can try this by yourselves. 3 marks, 3 minutes. Let's go. Lorato?
Ma'am, did you say you wanted the full coordinate?
Yeah, full coordinates,
Okay.
so X and Y.
Okay.
Cool. Okay, so based on that, I'll give you 1 more minute just in case, and then we'll have a look. Okay, let's have a see. Right, so if point of inflection, so you need to find your second derivative. So a mark for finding the first derivative, a mark for getting the second derivative, and then a mark for your final answer. Oh, Lorato, do you know what? I didn't even read my own question. I'm so sorry. It just said the x coordinate of f. So you just needed the x. It seems though we got different things. So just double check. If I then did ask you to find the full coordinate, we would substitute that in to my original equation of f. So f of negative 11 over 6, which should be...
Ma'am, I saw my mistake.
Okay, cool.
I said negative 4x squared instead of negative 11x squared.
Okay.
Yes.
Often it's just a silly little mistake. Right, so if I did ask you for the full coordinates, no, I'm not going to do that. Let's use a proper calculator. We would just sub it in and you would have gotten the following. (343 over 54). And so f would be at negative 11 over 6, 343 over 54. How delightful. What an absolute joyful answer.